Hi students, good morning everyone. Today we are going to discuss about fourth one, that is vertical circular motion. So circular motions mainly two types. One is horizontal circular motion and vertical circular motion. So first one, horizontal circular motion means here we can consider the same height. At any point we can consider the same height. But in vertical circular motion, we can consider the different heights at lowest point and highest point. Suppose here we can consider the vertical circular motion, vertical circular motion. So in this vertical circular motion, we can hang the a bob. So this is the bob. Bob weight always acting vertically downward direction, EMG, and tensional force acting upward direction. Tensional force acting upward direction. The length of this one string is taken to be L. Length of the string is L. And here we can observe the we can supply this some velocity at the lowest point. Here we can consider this is the lowest point A and this is the highest point C. Suppose the highest point C. So here pendulum is rotating half of the vertical circular motion. Then here bob move from here to here. That means here lowest point and highest point. In this case, at lowest point, the potential energy and the kinetic energy. We will find out the mechanical energy of the bob. So here, potential energy zero. Why potential energy is zero? So here, it can be considered a ground. Then there is no height. There is no height. Then height is zero. Then at at point A or lowest point, the height becomes zero, then potential energy is equal to zero. Potential energy becomes to zero. Then the total energy and mechanical energy is written as the energy E is equal to half mv square at point A of mva square plus potential energy zero. Then finally you can write a half mva square. So at lowest point, we will find out the two terms. One is the energy, another one tensional force. Then here, the tensional force is equal to at lowest point TA. So here tensional force acting upward direction and weight acting downward direction. TA minus mg, that is equal to here the centripetal force acting on the body, that is mv square mv and at a point A, that is mva square by, and here r square, in case we can replace the length L, that is Ta minus mg is equal to mva square by L. So this is the second equation. At point A, at lowest point, we will find out the energy. So here mechanical energy means sum of the potential energy and kinetic energy. Here potential energy is zero. Why the potential energy is zero? The string bob placed at the lowest point. Here there is no height, and then bob is moving at the point C or highest point. It reaches the some height. Then it is we can take the at point C. So at point D means this is the lowest point. And next one at point C. At point C means here highest point. Highest point also we will find out the tensional force and mechanical energy. So first we will find out the mechanical energy. but in case of lowest point, potential energy 0, but in case of highest point, there is no 0 in potential energy. So here the potential energy is equal to mg h, mg h, and here h is taken to be 2l, which is taken to be 2L. So here it can be circulator, vertical circular motion, and this one total height is h, and this length is L, and this length also L. Then height h is equal to L plus L 2L. Then h is equal to 2L. We can replace the potential energy is equal to mgh. mgh in place of h we can replace the 2L, then it can be written as 2mg into L. And also we can find out the total energy, that is total energy at point A, lowest point, and at point C, highest point, kinetic energy half mv square plus the potential energy 2mg L. So this is the energy at highest point, at the highest point. So energy and tensional force lowest point, and energy at the highest point. Next we will find out the tensional force at highest point. So tensional force, that is Tc plus so here tensional force acting downward direction, and weight also, bob weight also acting downward direction, same direction. Then we can write the Tc plus mg, that is equal to mc vc square by vertical circular motion mv square by L. But here the tensional force going to be 0. Tensional force is 0, and highest point tensional force is 0. How can we say that the tensional force is 0? So because the particle moving or bob moving vertically circular motion in a highest point reaches the highest point, then it becomes to less, or bob moving towards center or downward direction, then tensional force is 0. Then Tc plus mg is equal to mv square by L. Then tensional force is going to be 0. Then we can write mg is equal to mvc square by L. mvc square by L. So take a screenshot. Yes. Next one. So here we can write mg is equal to mc vc square by L. Here mm cancel. Then we can write vc square is equal to gl. And also we can write vc is equal to square root of gl. Square root of gl. And next from we can write the two energies equal. Then we can write the at point lowest point energy and the highest point energies are equal. So then we can write the, so this one is, so equal the two energies at lowest point and highest point. So that is half m v a square at lowest point, and highest point energy half m v a square plus, wait, lowest point va and highest point vc square plus 2 mg L. Then we can write here, we can observe the vc square. So here vc we can replace the vc square is equal to gl. Then we can write half m va square is equal to half m into gl plus 2 mgl. Then we can write here, we can take the common term, that is half mg. So first one we can remove the m, and we can remove the half, and we can take the 2 into 2 4. That is Va square is equal to GL plus 4GL. So GL plus 4GL, 5GL. Then Va square is equal to square root of 5GL. Va is equal to square root of 5G. So this is the vertical at point A, lowest point, the circular motion square root of 5G. Yeah. So I hope all of you understand. Thank you. If any problem in the video, please comment on the comment section. Thank you.